So we're going to show the importance of cleaning your data. I have some weblog data from a little website that I own, and we're just going to try to find the top viewed pages on that website. Sounds pretty simple, but as you'll see, it's actually quite challenging. So let's walk through a simple example. Well, actually it's not so simple, where I just want to figure out the top viewed web pages on my website. Sounds pretty easy, doesn't it? Well, let's see. So if you want to follow along, the top pages IPython notebook is the one that we're working from here. And let's start. So I actually have an access log that I took from my actual website. It's a real HTTP access log from Apache. And that is in your course materials. So I went and got this little snippet of code off of the internet that will parse an Apache access log line into a bunch of fields. So it contains things like the host and the user and the time and the actual page request and the status and the referrer and the user agent, meaning what browser actually was used to view this page. So this builds up what's called a regular expression, and we're using the RE library to use it. And that's basically a very powerful language for doing pattern matching on a large string. So by using this regular expression, we can actually apply that to each line of our access log and automatically group the bits of data, the bits of information in that access log line into these different fields. Okay. So if you do want to play along here, make sure you update the path to the access log to wherever you saved the course materials for this course. And let's go ahead and run this. All right, so we have a path to our data file. So the obvious thing to do here, let's just whip up a little script that counts up each URL that we encounter that was requested and keeps count of how many times it was requested. Then we can sort that list and get our top pages, right? Sounds simple enough. So we're going to construct a little Python dictionary here called URL counts. And we're going to open up our log file, and for each line, we're going to apply our regular expression. And if it actually comes back with a successful match for the pattern that we're trying to match, we'll say, okay, this looks like a decent line in our access log. Let's extract the request field out of it, which is the actual HTTP request, what page is actually being requested by the browser. We're going to split that up into its three components. It consists of an action like get or post, the actual URL being requested, and the protocol being used. So given that information split out, we can then just see if that URL already exists in my dictionary. If so, I will increment the count of how many times that URL has been encountered by 1. Otherwise, I'll introduce a new dictionary entry for that URL and initialize it to the value of 1. I do that for every line in the log, sort the results in reverse order, numerically, and print them out. So let's go ahead and run that. Oops, we end up with this big old error here, and it's telling us that we need more than one value to unpack. So apparently we're getting some request fields that don't contain an action, a URL, and a protocol. It contains something else. Let's see what's going on there. So if we print out all the requests that don't contain 3 items, we can see what's actually showing up here. So what we're going to do here is a similar little snippet of code, but we're going to actually do that split on the request field and print out cases where we don't get the expected 3 fields and see what's actually in there. So we have a bunch of empty fields. That's our first problem. But then we have this field that's full of just garbage. You know, who knows where that came from, but it's clearly erroneous data. So, okay, fine. Let's modify our script. We'll actually just throw out any lines that don't have the expected 3 fields in the request. And that seems like a legitimate thing to do because this does in fact have completely useless data inside of it. It's not like we're missing out on anything here by doing that. So we'll modify our script to do that. We've introduced this if len fields equals 3 line before it actually tries to process it. And we'll run that. Hey, we got a result. But this doesn't really look like the top pages on my website. Remember, this is a news site. So we're getting a bunch of PHP file hits. That's, Perl scripts. What's going on there? Our top result is this xmlrpc.php script and then wplogin.php, followed by the home page. So not very useful, robots.txt, a bunch of XML files. When I looked into this later on, it turned out that my site was actually under a malicious attack. Someone was trying to break into it. And this XMLRPC script was the way they were trying to guess at my passwords, and they were trying to log in using the login script. And fortunately, I shut them down before they could actually get through to this website, but this was an example of malicious data being introduced into my data stream that I have to filter out. So, by looking at that, we can see that not only was that malicious attack, looking at PHP files, but it was also trying to execute stuff. So it wasn't just doing a GET request, it was doing a POST request on the script to actually try to execute code on my website. Now, I know that the data that I care about, in the spirit of the thing I'm trying to figure out, is people getting web pages from my website. So a legitimate thing for me to do is to filter out anything that's not a GET request out of these logs. So let's do that next. So we're going to check again if we have 3 fields in our request field, and then we're also going to check if the action is GET. And if it's not, we're just going to ignore that line entirely. So we should be getting closer to what we want now. And yeah, this is starting to look more reasonable. But it still doesn't really pass a sanity check. This is a news website. People go to it to read news. And are they really reading my little blog on it that just has a couple of articles? I don't think so. That seems a little bit fishy. So let's dive in a little bit and see who's actually looking at those blog pages. If you were to actually go into that file and examine it by hand, you would see that a lot of these blog requests don't actually have any user agent on them. They just have a user agent of dash, which is highly unusual, because if a real human being with a real browser was trying to get this page, it would say something like Mozilla or Internet Explorer or something like that, right? Or Chrome. So it seems that these requests are coming from some sort of a scraper. Again, potentially malicious traffic that's not identifying who it is. So, okay, maybe we should be looking at the user agents too to see if these are actual humans making requests or not. Let's go ahead and print out all the different user agents that we're encountering. So in the same spirit of the code that actually summed up the different URLs we were seeing, we can look at all the different user agents that we were seeing and sort them by the most popular user agent strings in this log. And you can see most of it looks legitimate, so it's at least, if it's a scraper, and in this case it actually was a malicious attack, but they were actually pretending to be a legitimate browser. But this dash user agent shows up a lot too. So I don't know what that is, but I know that it's not an actual browser. A real browser, would look something more like this. The other thing I'm seeing is a bunch of traffic from spiders, from web crawlers. So Baidu is a search engine in China, Googlebot, just crawling the page. I think I saw Yandex in here too, a Russian search engine. So our data is being polluted by a lot of crawlers that are just trying to mine our website for search engine purposes. And again, that traffic shouldn't count toward the intended purpose of my analysis of seeing what pages actual human beings are looking at on my website. These are all automated scripts. All right, so this gets a little bit tricky. There's no real good way of identifying spiders or robots just based on the user string alone, but we can at least take a legitimate crack at it and filter out anything that has the word bot in it or anything from my caching plugin that might be requesting pages in advance as well. And we'll also strip out our friend single dash. So we will once again refine our script to, in addition to everything else, strip out any user agents that look fishy. And what do we get? All right. So here we go. Well, this is starting to look more reasonable for the first 2 entries. The home page is most popular, which would be expected. Orlando headlines is also popular because I use this website more than anybody else and I live in Orlando. But then we get a bunch of stuff that aren't web pages at all, a bunch of scripts, a bunch of CSS files. Those aren't web pages. So again, I can just apply some knowledge about my site where I happen to know that all of the legitimate pages on my site just end with a slash in their URL. So let's go ahead and modify this again to strip out anything that doesn't end with a slash. Finally, we're getting some results that seem to make sense. So it looks like that the top page requested from actual human beings on my little no hate news site is the home page, followed by Orlando headlines, followed by world news, followed by the comics, then the weather and the about screen. So this is starting to look more legitimate. If you were to dig even deeper, though, you see that there are still problems with this analysis. For example, those feed pages are still coming from robots just trying to get RSS data from my website. So this is a great parable in how a seemingly simple analysis requires a huge amount of pre-processing and cleaning of the source data before you get results that make any sense. And again, make sure the things you're doing to clean your data along the way are principled, and you're not just cherry-picking problems that don't match with your preconceived notions. So always question your results, always look at your source data, and look for weird things that are in it. All right, if you want to mess with this some more, you can solve that feed problem. Go ahead and strip out things that include feed because we know that's not a real web page, and just to get some familiarity with the code. Or go look at the log a little bit more closely. Gain some understanding as to where those feed pages are actually coming from, and maybe there's an even better and more robust way of identifying that traffic as a larger class. So feel free to mess around with that. But I hope you learned your lesson. Data cleaning, hugely important, and it's going to take a lot of your time. So it's pretty surprising how hard it was to get some reasonable results on a simple question like what are the top viewed pages on my website? And you can imagine if that much work had to go into cleaning the data for such a simple problem, think about all the nuanced ways that dirty data might actually impact the results of more complex problems and complex algorithms. Very important to understand your source data, look at it, look at a representative sample of it, make sure you understand what's coming into your system, and always question your results and tie it back to the original source data to see where questionable results are coming from.